Welcome guys for the another problem to solve. Let's move on to another question, which is about the question number 5 in the open system and question number 18 in the first law. Need number 2. Let's read out this question. Air at 4 bar and 80 degrees centigrade flows into a small turbine at a velocity of 40 meters per second. The air leaves the turbine at 1.5 bar and 10 degrees centigrade with a velocity of 125 meters per second. So if the shaft work delivered by the turbine is 65 kilojoules per kg air, what is the heat transfer per kg of air flowing? Okay, so this is a question which has been asked in June 2012 for 7 marker question. So let's try to write down the given data at two different states and try to draw the sketch and the formula for steady flow energy equation and apply the values and then calculate the values. Okay, so let's start with the first one, writing out the given data at your two states. Given data at state 1. Let's try to write out the state 1. P1 is given as 4 bar and T1 is given as 80 degrees centigrade. V1 is given as 40 meters per second and at state 2 P2 is given as 1.5 bar and T2 is given as 10 degrees centigrade. V2 is given as 125 meters per second. Okay, and also such a way like the shaft work is given, the shaft for d dash w by dm is given as 65 kilojoules per kg. So this is the things which is given, and what is we need to find? To find d dash q by dm. This is what we need to find, and assumptions are same as your potential energy changes are neglected and the steady flow equation. Okay, so let's try to draw this sketch. Shaft work at the end, and this is in the properties, out the properties. Okay, so this is a sketch for the turbine which is running, and next let's try to write down the formula, as you know, for the steady flow energy equation. D dash q by dm plus h1 plus v1 square by 2 plus zz1 is equal to d dash w by dm plus h2 plus v2 square by 2 plus zz2. So this is the things which is the formula, and as you know, potential energy changes are neglected. And next, let's try to directly substitute the value to calculate. As you know, right, so here, as you know, the enthalpy H is equal to U plus PV, but here for this is where U plus PV is valid for a steam, where you can note down at a pressure, at a temperature, whatever it is given, you can directly calculate your internal energy as well as specific volume by going through the steam tables. But here the system, it is not a steam, it is an air. For air you cannot apply, where enthalpy U is H is equal to U plus PV, where you can write enthalpy H is equal to Cp delta T. So this can be written as H1 is equal to Cp T1 and H2 can be written as Cp T2. Okay, so this being as an air, as you know, Cp for air is 1.005. Directly can calculate the value of H1 as Cpt1 1.005 into 353 Kelvin, which can be written as 354.76. As well as you can calculate H2 value. H2 is equal to Cp T2 1.005 to 83 Kelvin. So this can be written as 284.4. Okay, so H1 and H2 is known. Now directly substitution in the formula of your steady flow energy equation, then you can get the values. That is 354.76 plus 40 square by 2 plus d dash q by dm is equal to 284.4 plus 125 square by 2 plus 65. So finally from this value we can calculate your d dash q by dm as 8161.9 minus 1154.6. So finally I got the value of the d dash q by dm as 7071.14. This is actually in kilojoule per kg. Okay, so this is the final value which I got. Okay, this question is asked in 2012, 7 marks question. Hope this solution is clear with a simple one. Let's move on to another problem in another session. Thank you.